Dear students, I am Lakshmi Hebbar here. Now this is the third session in aromatic hydrocarbon, in which we need to interpret orienting or directing influence of substituent which is present in the mono-substituted benzene while we carry out dye substitution by electrophilic method. In this part 1, we discuss about electronic interpretation of orienting influence of electron withdrawing groups on electrophilic substitutions. Here we consider nitro group, sulfonic group, carboxylic group and aldehyde group which are mentioned in your syllabus. And in the second session, we learned about electrophilic substitution of benzene to get mono-substituted benzene. Now, this mono-substituted benzene undergoes further electrophilic substitution. We get either a mixture of ortho and para di-substituted compounds or meta di-substituted compound. Now, if I consider this as mono-substituted benzene, where the substituent present in the compound is indicated by letter S instead of E for our convenience. Now here this E is second electrophile which is taking part in the reaction. Now here we are familiar with the relative positions of substituents. Now if I consider this as the first position, now this is second position. Now this 1,2 position is known as ortho position. Similarly 1,6 also ortho position, and 1,3 position and 1,5 positions are known as meta positions, and only one para position is there, that is 1,4 position. These are all we had studied in the lower classes. Now this mono-substituted benzene is undergoing electrophilic substitution by E+. Then we get two types of products. In the first case, the mixture of ortho di-substituted benzene and para di-substituted benzene are obtained. In the second case, it may give meta di-substituted benzene. Now the position to which second substituent goes in the mono-substituted benzene depending upon the nature of the substituent which is already present in it. Now if I consider phenol as an example in which OH group is present on the benzene. So this is mono-substituted benzene and it is nitrated with the help of nitrating mixture HNO3 and H2SO4 concentrated. We get orthonitrophenol along with paranitrophenol. Now groups like hydroxy, methyl, chloro group, amino groups which are known to be electron donating groups always direct or orient the second substituent, that is here nitro group, to the ortho position and para positions. Therefore, these groups are called as ortho para directing or ortho para orienting groups. Now these are also may be called as activating groups. On the other hand, the substituent already present is electron withdrawing like nitro group, sulfonic group, aldehyde group, carboxylic group, etc. The second substituent always occupies meta position and hence these electron withdrawing groups are called as meta orienting or meta directing groups, and also they may be deactivating groups. Now for this we take the example of nitrobenzene where it is nitrated, that is electrophilic substitution by nitro group. The product we obtain is meta dinitrobenzene. Now this therefore may be known as orienting influence of the substituent groups. Now this orienting influence should be discussed with the help of electronic effects under the heading electronic interpretation for orienting influence. Let us take the first case of meta directing influence. Here ring deactivation also we should discuss. For this we consider again nitrobenzene where benzene ring is attached to nitro group. Now we can observe the structure of nitro group where the nitrogen is linked to the ring carbon atom, that is why it is called as key atom. Now this key atom is linked to the electronegative atom by double bond. Now this double bond is conjugated with the ring double bond. Same is the case in the other electron withdrawing groups. We have See here carboxylic group. Here also the carbon atom is key atom which is linked to the oxygen electronegative atom by double bond, and in the aldehyde also same is the case, and in the sulfonic group the sulfur, the key atom is linked to the oxygen atom by double bond, and which in turn linked to the ring carbon atom which is having double bond. Therefore, we can say that all meta-directing groups contain key atom that link to the electronegative atom like oxygen through multiple bond which is conjugated with ring double bond. Now here oxygen is more electronegative than nitrogen. That is why this double bonded electrons, that is pi electrons, are moving towards the oxygen. So this nitrogen atom gets positive charge, and hence this ring double bond which is conjugated is shifted to this position to neutralize this nitrogen. Therefore, the ortho carbon atom, that is this carbon atom, will get positive charge like this, and this oxygen gets negative charge. And here you can observe this is coordinate bond in the structure of nitro group. Now this positive charge again is conjugated with this double bond, so the pi bonding electrons are delocalizing like this. So here para position also gets positive charge, and the positive charge present in the ortho position will be neutralized. Similarly, shifting takes place here also to get the positive charge on the ortho position. So these three are called as resonating structures of nitrobenzene. Now for that we can write the resonance hybrid. So where oxygen atom is having partial negative charge and this bond is breaking, this bond is forming, and these are partial bonds, and these two ortho positions and para positions are having partial positive charge. So here you can observe there is minus R effect by the nitro group on the benzene ring. That is, nitro group withdraws the electron from the phenyl group by resonance effect, minus R effect, along with the minus I effect, that is inductive effect, due to the electronegativity of this nitro group atoms from the phenyl. So both inductive effect and resonance effect jointly withdraw the electron from the phenyl group. So it renders the aromatic ring poorer electron source than the benzene. That is why aromatic ring gets deactivated towards the electrophiles, because if electrophiles to be attracted, then the substrate should have more electron density. Here electron density on the phenyl ring is decreased. That is why it is called as deactivated towards the electrophile. But here you can observe the withdrawal of electron from the phenyl ring occurs more ortho and para position, but not from the meta position, because meta position is not involved in the resonance. So comparatively the electron density is less at ortho position and para position. So now if present nearby nitrobenzene, then electrophile is attracted by the meta position which is neutral rather than the ortho and para positions which have positive charge. So they will repel electrophile. So electrophilic substitution occurs preferentially at meta position. Now this can be cleared if we go through the resonating structures of benzene ring which are containing other electron withdrawing groups as well. Now in the case of benzoic acid, seen that carbon atom, the key atom, is linked to the electronegative atom by multiple bond which is conjugated with the ring double bond. That is why the delocalization of the pi electrons of the benzene ring are to the oxygen atom takes place, resulting in negative charge on the oxygen atom and positive charge on the ortho carbon atom, and similarly it will be delocalized to give the three resonating structures like this, and the resonance hybrid for this benzoic acid may be written like this. So here also minus I and minus R effect will be responsible for this decrease in the electron density in the phenyl group, and that too at ortho and para position in comparison with the meta position. So when it finds the electrophile, so ortho and para position repel the electrophile, but meta position will attract the electrophile by having more electron density comparatively. So here we can say that if benzoic acid is nitrated, we will end up with meta nitro benzoic acid. So next is the case of benzaldehyde, where aldehyde group again fulfills all the things we discussed already in the case of benzoic acid. So here you can find the resonating structures of benzaldehyde, and in the resonance hybrid again ortho and para positions are having relatively less electron density than the meta positions. If it finds an electrophile, so meta position will attract electrophile and combine to give the meta substituted benzaldehyde. Same is the case for sulfonic acid, benzene sulfonic acid. Here also sulfur is the key atom which is linked to the oxygen atom by double bond, which is conjugated with the ring double bond. So to give these resonating structure by delocalization of pi electrons from the phenyl ring, and you can write the resonance hybrid like this. Again you find the ortho and para positions are relatively less electron density than the meta position. So if we carry on the electrophilic substitution on this sulfonic acid, it will end up with the meta substituted benzene sulfonic acid. So like this, whenever there is electron withdrawing group in the mono substituted benzene, then the di substitution is taking place by electrophilic reagent electrophile, then we will end up with the meta di substituted product. And also this reaction is slow because phenyl ring is deactivated towards the electrophilic di substitution. So here we understood about electron withdrawing group, meta directing influence, deactivation of phenyl ring towards the electrophilic di substitution, etc. So here we end the session and meet in the next session with the second part of the electronic interpretation of orienting influence of ortho para directing groups.